Yo, what's up guys? Welcome to day 3 of week 2 of the AI journey. And as you know, in the last video, we were implementing the model of our MNIST classifier, how it will flow through the neural network. So in today's video, we're going to be building the actual functionality. We're going to be implementing the training loop and the evaluation function. So we're going to have two functions. One function to train the model and another function to evaluate the model on test data. So we want the model's accuracy on the test data to be really high and also on the train data to be high. The thing is though, usually when you train a model on data, it gets used to the training data. So when you test it on a different set of data, it usually kind of goes down in accuracy. So we're going to look into that, see how it performs, other stuff. And yeah, that's pretty much it for today. We're just going to get straight into it. I'm going to do a quick 4 hours. This morning, I'm probably going to learn a few stuff first in the first hour, and then we're just going to get to coding for the next 3 to 4 hours. So yeah, I'll see you guys when I'm done with that, I guess. So yeah. Alright guys, we're finally done with the tasks for today. I'm going to really quickly go through everything I've done. So I'll just give an overview of what I did. It's really important stuff. This is basically like most of it, right? Most of it was on today. So we implemented this function called train1epoch. This function is responsible for training the model. As you can see here, we're loading the input data and the output data from the data loader. If you guys know what data loader is, it's from the last video. No, from the last 2 videos, the data loader basically loads up the data stored in the CSV file. I don't know if I can find it here. Data CSV file. Somewhere here. Okay, wherever it is, I can't be asked. It loads the data from the CSV file into batches of 64 images each, and that's basically what happens. It goes through each of those 64 images, gets the input, gets the required output, what's meant to be. If it's for example, if it's a 5, the output will be a 5. That's what's meant to be. And then the model is just basically meant to learn off that. And then we're going to give it test data, which is going to be in the evaluation section. And it's going to basically try and guess, oh, you're giving me a 5, you're giving me a 2, basically, something like that. Yeah, and as I mentioned earlier, the evaluate function is basically just to test the model on fresh new output. So that's basically going to be the test data. So if we keep going down, you can see we're just going to run a quick short training loop. And here you can see in the evaluate function, we're passing through the test loader, which has the test data. And in the training loop, we're passing in the train data, right? So here, as you can see, in each epoch, an epoch is basically an iteration of training the model. So each iteration, it gets more accurate and more accurate. As you can see here, the accuracy goes from 0.9 all the way to 0.98 really fast in just 5 iterations. This is for the train data. So on the train data, it's getting really accurate because that's what it's operating on. It's obviously memorizing some of the patterns and memorizing some of the inputs and outputs. But when you look at the evaluation data, so this is on test data, right? You can see it goes from 0.95 to only 0.97. So it's not as good on fresh new data because it can't cheat and memorize stuff, but it's still doing decently well. It's still improving. And that's basically what we want to kind of see. Here we just plotted, we use matplotlib as usual to plot the curves. It makes it more visible. And that's basically what we kind of want to see. Is it working exactly as we expected? It's not really. I mean, I don't think there's anything. But guys, if there's anything off, if there's anything I'm missing, just let me know, because I'm literally not the expert here. I'm just literally learning, right? So yeah, but this is what I expected to happen. So yeah, that's pretty much it for the day. We've implemented the functionality. We've tracked the loss, as we can see, per iteration. And tomorrow is the big day. Tomorrow is the GPU day. We're going to actually use a GPU and see how much better we can make our model train. The GPU doesn't actually make it more accurate, it only makes it faster. So it makes it faster to train, but that still is really important because you don't spend hours training your model. And I know next week when we look into these other like transformers, I know it's going to require a lot of time to train some of those models. So definitely the GPU is required. And as you guys know, I have an RTX 4070. I've not used it in like a year, so I'm going to actually put it to good use. And yeah, so that's it. See you guys tomorrow. Yo, what's up guys? Welcome to day 4 of week 2, and today we're going to be using our GPU for the first time to actually train our models. So basically, if you haven't been following along, I've been using my MacBook Air every single day for the past like 2 weeks, and we've been basically running our models on the MacBook's CPU in the system on chip, right? But now we're finally going to move over to my PC. I'm going to use my 4070 graphics card and see how much faster I can make this model run. Obviously, if you're using a GPU, it can obviously do like thousands more of matrix multiplications and all these other functions in parallel, right? So it's going to speed it up by like it's going to speed up exponentially. Also, I remember that I have to start studying data structures and algorithms, so I basically have to start my leak code grind. I'm going to probably make a whole new table with the days, and I'm probably going to be doing like 5 leak code questions a day, maybe, and try and get to over 200 or 300 done over the next couple of months. So yeah, I'm going to be doing that in parallel to this machine learning journey structure I have right now. I just wanted to let you guys know, because it's obviously really important for getting interviews at the big tech companies. You're going to need really good knowledge of a lot of data structures, so that's why I'm going to be doing that. But yeah, apart from that, there's no other update. The reason why we're starting so late today is because I had to set up my PC. It had so much problems. I had to basically like reset everything, and I'm reinstalling Windows, reinstalling Linux, dual booting it, whatever. And yeah, so now it's good. We're going to start at 9, and I'll see you guys after 4 hours. Alright guys, we're finally done with the study session. Honestly, there's a lot of stuff I have to cover today. Ignore the leak code grind. So basically, actually let me explain that. So I have made a new section for leak code. This is how much questions I'm going to be doing every day. Every day I'll be doing at least around 5 easy questions with 2 medium questions. So seven leak code questions a day. I don't know how doable that is. I'll have to find out because I'm starting tomorrow. But I think it's doable. We'll see. But I'm on week 2. I haven't taken stuff for day 3. But on day 4, week 2, I managed to get my GPU to work because I spent so long this morning trying to set up my PC, setting up CUDA so I can use my GPU to train the model. And like the results are it's so funny. The results are so funny. But basically, in conclusion, I brought the time library, and we're tracking the time for how long it takes my M4. Right now I'm on the M4 MacBook Air. Right now we're tracking the time for how long it takes my laptop to finish training just 5 iterations of this, right? So when we run this, as you can see here, sometimes going past, it takes 8 seconds for this M4 Air to run this, right? So I got the same code on my PC, switched it from CPU to CUDA, so it's using my GPU, and we're getting 19 seconds. That's the funny part. So it takes longer for my 4070 GPU than my well, it's not a CPU, it's an M4, it's a system on chip, but that's really impressive. Like Apple Silicon is really impressive that it's faster than my GPU, but that's only because we're dealing with such a small amount of data. So the GPU doesn't really have enough time to shine. So that's basically what happened. So it's really interesting. That's pretty much the main point of today. We're just trying to figure out how much speed improvement we get from using our GPU. It was actually nothing for the amount of iterations we had. It was basically slower using the GPU. But in real life cases, in most cases, the GPU will be way faster. And in the future, probably next week, when we get into the convolutionary neural networks, we'll probably see how much faster the GPU can actually make these models train. So yeah, that's pretty much it for today. Spent a lot of time on just getting this to work, sadly. But yeah, finally going to go to the gym, do a quick workout, come back, and I'll see you guys then. Alright guys, we're back from the gym. We're finally done for the day. Tomorrow we're probably going to be doing a bit more plots and visualization of like the data, seeing how the model is performing, you know, in a more visual way. But right now I'm basically going to start doing some LeetCode questions. I'll be doing a lot more data structures and algorithms now. I'll be mixing it up every day, so that'll be a big portion of the videos now. So yeah, if you finish early tomorrow, I'll just fill up the extra time with LeetCode questions. And yeah, that's pretty much the plan for now. So I guess I'll see you guys in the next one.